Today we're going to learn about different types of bonds. And before we get into that, I want to discuss a little bit more about the periodic table and some things you can learn from that. So you may notice this dark line starting here by boron going down in a kind of staircase fashion. Now, to the left of this line are what we refer to as metals. Now, metals are normally lustrous and they're ductile, meaning you can move them around and they're kind of malleable. To the right of this line are the nonmetals. And nonmetals are normally very dull looking and brittle. And then we have a few species that are right on this line on either side of it, and these are referred to as the metalloids. These normally have characteristics of both metals and nonmetals, and typically they're found for things like semiconductors and the like. Now, we're going to focus mainly on metals and nonmetals and how they can come together to form different compounds and bonding. And one of the main types of bonding is ionic bonds. And for ionic bonding, this is when we have a transfer of electrons. This means that one atom is going to give up an electron and another atom is going to take in that electron. And typically this will happen between metals and nonmetals. So a metal will normally give up an electron and the nonmetal will receive those electrons. Another common type of bonding is covalent bonding. And this is when we have a sharing of electrons. So both species will have the electron around it. The electron will essentially go around one atom for a little bit of time and then go around the other atom for a bit of time. And this is essentially what holds that bond together, as opposed to ionic bonding where essentially we have the opposite charges holding everything together through Coulombic interaction. In covalent bonds, it's the movement of this electron that is keeping everything together. And this occurs when we have two nonmetals coming together. And then the last type of bonding is referred to as metallic bonding. And this is when we have electrons that aren't really associated with one nucleus or the other. I like to equate this to going to a playground, and normally when you go there you see a bunch of parents and they're all kind of scattered about the playground a little bit, mostly around the edges is what I've seen, and we can consider these to be the nuclei. And they have a bunch of children running all around the playground and have tons of energy, and these are similar to the electrons. Now, you may have some electrons running through, or some kids running through the playground, and maybe they're not doing something right. Maybe they're about to get in the way of someone on the swing. Maybe they're not sharing the slide very well. And no matter which parent is around there, or nucleus if you will, they will help direct that kid or electron. And so again, it's kind of no one nucleus is in control of those electrons. They're all kind of guiding them in some sense, but it's delocalized. And so this is normally referred to as a sea of electrons. And this occurs when we have a metal and metal come together. All right, and normally this is why metals can bond together so easily, and this is why they're very conductive, because their electrons are able to more freely move. All right, well, hope you learned something, and I will see you on the next video.